In this video, I will go over the theory for finding the magnetic field of a single moving charge, and this is what we call, this is the Biot-Savart law for a single moving charge. We will see the Biot-Savart law, how you can apply it to different configurations other than this one. So in this case, what I have is a single moving charge. So let's say this is charge Q1. Now, this is the charge that will create the magnetic field. And because this charge will create the magnetic field, this is what we call the source charge. Now, with the Biot-Savart law, I can find the magnetic field at the observation location. So let's say that we say this is the observation location. And these ideas are similar to what we did for the electric field. Now, I do need to define a coordinate system. So let's say this is, that'll be the x and that'll be the y. Zero, x, y, and I cannot show the z will go out of the board. Now, I have a number of things here. Okay, it is true that using the Biot-Savart for a single moving charge is not easy. Now, mu naught over 4 pi, this is a constant. Q1 is the source charge, okay, and this is important to remember. Q1, the Q that you have in Biot-Savart law for a single moving charge, this Q is the charge that is creating the magnetic field. Now, V1, okay, there is a V1 vector here. This V1 is the velocity of the charge that creates the magnetic field. So V1 is the velocity of the source charge. Let's draw that. Let's say that the source charge is moving this way. V1, that's the velocity you need here in the expression for the magnetic field of a single charge. Now, this gets a little bit more complicated. So let's do this here from the origin to the location of the source charge. And this one, these are two position vectors. I'm going to talk about them. This is the vector R1. And this is the vector R2. R1 is the position of the source charge. R2 is the observation location. You need to know the positions of both of them. You need to know where is your source charge. You need to know where you want to find the magnetic field. Now, once you have those two vectors, and I assume that I need to assume that you have them, you have the x, y, z coordinates of R1 and R2. The next step that you will do, so let's say this is step 1 in your calculations. This is step 2 in your calculations. Step 3 will be to find the relative position vector of the observation location with respect to the source. And you will find that by doing R2 minus R1. Or if it is easier to remember it, you will do r obs minus r source. Okay, whatever way works for you. Now, once you have this, next step, you will find the magnitude of this vector, the one you found in step 3. And to find the magnitude, you will do the square root of the 3 components squared, the sum of x squared plus y squared plus z squared. Next step, you will use your results from steps 3 and 4 to find the unit vector. So you will do the vector that goes from 1 to 2 divided by the magnitude that you found in step 4. Now this will give you a vector. It will also have x, y, z. Just to make it clear, from step 3 you will get a vector. You will have x, y, z components. From step 4 you will find a number. Okay, the magnitude simply shows you the strength, the magnitude of the vector. This is just a number. From step 5 you will find a vector because you are dividing a vector with a number, and this calculation will result in another vector. Now these first few steps are similar to what you did for the calculations of the electric field, so there is nothing new here. Now, at least not until this point, now is where the complicated stuff begin, because for the next step you will have to do this calculation, v1 cross with r hat from 1 to 2. This is a complicated calculation because it's a calculation of the cross product. You do have to be very careful when you work on this step. v1 is a vector, the unit vector is another vector, and you're finding the cross product. As I said, I do recommend that you take your time to make sure that you do this calculation correctly. And this is a cross product between two vectors, so this will give you a vector. Let's make some notes. So this will be vector. Step 2, you got a vector. Step 3, you got a vector. Step 4, you got a number. Step 5, you got a vector. Step 6, this should also be a vector. And step 7, the last one, is to combine everything and do the constant q1 Okay, if you take a look here, at this point I have everything. The constant is the constant. The charge, you should know this number. From step 6, you have the numerator. This is a vector. And from step 4, you also have the magnitude of the vector r. So at this point, we have everything, and you can plug in all the numbers and see what you get. And you should get at this stage a vector because the magnetic field is a vector, so you should find x, y, z components for the magnetic field. So the difference between the magnetic field calculation from a charge and the electric field is this step where you find the cross product, and this makes things somewhat complicated.